force, correct?
Yes.
Okay.
Yes. All right, so the total force of zero is one interpretation. What's another interpretation of equilibrium? From Newton's second law, if the total force is zero, what else has to be zero?
Velocity and acceleration?
Well, part right.
Acceleration, not velocity.
Right. Acceleration is zero.
Okay.
F equals ma. If F is zero, A is zero.
Yeah.
And if acceleration is zero, what else is true?
Yeah, velocity is constant.
Yeah. Those are the three things right there. If it's in equilibrium, I know acceleration is zero, I know the total force is zero, I know that the velocity is constant, or change in velocity is zero. If one of those is true, all three of them are true.
Yeah, yeah.
Well, that response explains part of the test. So if it's in equilibrium and we get to the acceleration phase, because we've already done the force diagram, what do we pick for the direction of acceleration? If it is zero. Remember that we choose our coordinate system so that one of our equations, if we have two equations for a mass, one of the equations will be set equal to zero. But in this case, since acceleration is zero, what coordinate system will work best?
Is it the third one, the one with the 1/2 AT squared?
Oh, no.
We moved on from that, didn't we?
Wait, why are we bringing up?
Yes, we have to follow that.
Okay.
I thought you said direction.
The direction of our coordinate axes. If acceleration is zero, how do we pick our coordinate axes?
Just that up.
I guess we just choose a direction.
Yeah. Now, my recommendation is picking a direction so that we have to break up as few vectors as possible. I know for the 3 kilogram mass, I have tension going up this way, I have normal force this way, and I have weight going straight down. If we pick our coordinate system, same as we did before, I only have to break weight up. If I pick this system right here, then I'm breaking up tension and I'm breaking up normal force. So the recommendation, stick with the same. The only thing that is going to change, especially since we've already done this, the only thing that changes is that that's now zero and that's now zero. And the advantage of not plugging in numbers too soon is we can get away with that. So that's zero, that's zero, that's zero. So looking at this equation right here, I'm trying to figure out what is theta 5 so that this can be true. And so I'm solving for theta 5, and I end up with, well, actually now I have g common so I can get rid of it, but I have sine of theta 5 is equal to m3g sine theta 3 divided by m5g. G's can cancel. So I'm left with 3 times the sine of 30 degrees over 5. Whatever that is. So that's about 0.3. So this would be the arc sine of about 0.3. Which is, let's see, 0.3 times 7. Around 18 degrees.
Oh, this is you. What's the number?
What's the number?
After arc side?
Oh, it's about, it's approximately 0.3. I you know, doing that in my head, so.
No, you're, oh, I don't know. Well, the answer's
17.458.
All right, 17.458.
yeah.
So on a test problem a couple of years ago, last year, sometime in the past, I had this situation right here. I started out with it's an equilibrium. What is I gave everything but one of the angles, gave the angle. Then I either doubled the angle or cut it in half, which will at that point make it clear which way it's going to go. Then I asked what's the acceleration, and then I threw friction in on one side and said what's the acceleration. So again, just variations of a theme. Questions?
Is this a test level problem?
Excuse me?
Is this a test level problem?
It's part of a test level problem.
Could you do it with friction?
All right, now
Friction or friction?
Friction.
with friction, we run into a situation. If I give you friction for both of these, then it gets a lot trickier if it's not moving about how much friction is actually acting on which one. So I'll give you friction for one of the sides. The other side we're going to keep frictionless. So we have theta 5 is 17 point something degrees. Let's go ahead and make it sure that it is, well, if I threw friction in right now, it's not going to slide because, well, actually, what would the friction force be given the situation if I suddenly gave it friction? Or I gave it a coefficient of friction, not 0. What would be the desired direction of movement?
Desired direction would be the opposite direction of friction.
Sorry, what was that, Talon?
The desired movement will be in the opposite direction of friction.
Yeah, which way of friction be acting?
So you can look down.
Which way is it moving?
Which way does it want to move?
Friction's going this way.
If it were frictionless, which way would it move? Pardon?
Down?
What is the equilibrium?
It's not moving. Oh, the front side.
We solved the problem assuming that it was in equilibrium to begin with. We haven't changed anything yet. Now, I would need to establish either it's in static or dynamic equilibrium. If it's in static equilibrium, it has no desired direction of movement. So friction wouldn't act. It's like having a box on a level floor. However, some might call that a trick question. Some might call it a gift. Let's double this. So doubling it's going to put it to about 35 degrees. So if that's a 35-degree angle, now which way is it going to slide? It's going to slide generally to the To the left or to the right? Or if it were frictionless, which way would it slide?
The right.
Yeah. It's gonna go like that. So in our new problem, my acceleration is in that direction. I'm gonna flip around my I5 hat and my I3 hat. We're gonna put friction over here of US is 0.5, UK is 0.3. What changes in our force diagram?
What side is the friction on?
Friction's on this side. That was my intent, that arrow there. And then I changed my mind, I was gonna do that. Friction's on the left-hand side. So what changes in my force diagram? Acting.
Friction will be going in the opposite direction.
I think that's what you said.
Yeah.
All right, my equations of motion will look very similar to what I had before, except the signs have now flipped for the I hat equations. J hat hasn't changed, so why don't I just write those down? So my J3 hat equation is going to be Y3 minus W3 cosine theta 3 equals 0. My J5 equation becomes W5 cosine theta 5 minus Y is 0. All right, someone not Mirage. She did it last time. Someone else's turn to shine.
What's the question again?
Equations of motion, the I3 hat and the I5 hat equations.
The new ones.
Yes. I find it hard to believe only one person in the room can do this.
W3 cos theta 3 minus Y3?
That is the,
No, I'm wrong.
that's
That's
the
the wrong
J3 hat.
Sorry.
Dr. Fox, can you label the Y on J5?
Thank you.
Would I hat 3 be the force of tension minus weight sine theta 5 minus friction?
Wait, which one are we doing?
Oh, weights, yeah,
Sine theta 3
sorry.
minus friction equals,
Mass times acceleration, which is 0. Mass times acceleration, and acceleration would be 0, right?
no, acceleration would not be 0. We changed the angle
Oh,
so that it does want to slide.
okay, so just mass 3 times acceleration.
Any other equation? What's the worst that's going to happen?
Weight
You get it wrong.
of
All right.
5, weight of 5 sine theta 5.
what we're doing the I5 hat equation, we're doing this right here.
Okay, yes.
So you got all the ones in the positive direction, minus the ones in the negative direction.
Force, or friction,
No friction over here.
tension
Tension, yes.
equals
So isn't there supposed to be friction in there
5
somewhere?
times acceleration.
Yes. No, I only put friction on one side.
Oh, okay.
So we have one side that has friction, one side that's frictionless.
It's giving to this one.
It becomes incredibly difficult if it's not to, if definitely is sliding, it's simple to have friction on both sides. If it's not sliding, it becomes a lot more difficult to determine that if I have friction on both sides. All right, we have our equations of motion. Now what?
Now we do substitution.
Yeah, all right.
Yay.
So ft minus m3g sine theta 3 minus, what friction formula are we going to use?
Static first.
Yeah, we have to establish is it moving or not. So mu s y 3 equals m3a. Y3 is equal to m3g cosine theta 3. And m5g sine theta 5 minus the tension is equal to m5a.
Oh, can you explain why it's the static friction times the normal contact? I mean the normal force?
We have to establish is it sliding or not.
Oh, and like if there's friction, then there's normal force?
Well, yeah, well, if there's friction, there's definitely normal force. I mean, the formula for friction is the coefficient times the normal force. Or I guess this is maximum static.
Oh, yeah. I remember, sorry.
Okay. Now we're at the solving phase. I can pop that into here. And if I do that, I get ft minus m3g sine theta 3 minus mu s m3g cosine theta 3 equals m3a. I now have these two equations right here. You can solve for the tension in one and plug it into the other, since my two unknowns are tension and acceleration. So plugging, or I can just add the left-hand sides, add the right-hand sides, just like just my go-to. So I'm left with m5g sine theta 5 minus m3g sine theta 3 minus mu s m3g cosine theta 3 equals m5a plus m3a. So, add the right-hand sides, or the left-hand sides, add the right-hand sides. And solve for acceleration. So acceleration would be that whole big thing right there. m5g sine theta 5 minus m3g sine theta 3 minus mu s m3g cosine theta 3 over m5 plus m3. And then plugging in numbers. And I made it a 35-degree angle. 35 degrees. Minus 3 times 9.8 times sine of 30 degrees minus 0.5 times 3 times 9.8 times the cosine of 30 degrees, all divided by 8. end up with
I tried so hard to not make a mistake. Yeah, it's because you added the oh, okay. Excuse me. Okay, now I'm gonna add that by 5 plus 3.13 positive 3.13. Which means that it's moving, so now we will just substitute for it.
yes. We have established, assuming, did anyone else get the same thing?
I didn't finish typing it in yet. Could you, stop that, please? Sorry.
You did not get the same thing, Ash? What'd you get?
Number of 10,000.
Yeah, something seems off there.
Oh. Oh, I thought it was. Dr. Fox.
I do know it's not in free fall. We should get something less than 9.8.
I was just gonna ask when we were answering like the original problem before we started talking about equilibrium and everything. When we were originally doing like that,
Yes.
when we tested out the static thing, did we multiply it by the normal force then too? Because I don't remember. Or is it only now? Because I'm so sorry. I forgot we added friction. No, stupid question. Pretend it didn't happen. We're good.
I can pretend, but it is recorded.
Well, you know, trauma erases memories, so just pretend it's trauma, we'll be fine.
Hey, you know, I was raised by a dad who thought if you ignore the problem, it doesn't exist.
Do you have any childhood memories?
Yes, that's one of them.
That's a shocker.
Anyone else get 3.13?
I got